Number 13, it asks us to solve. Notice this is a degree 2. The fact that it is a degree 2, we cannot solve it our regular way. It's going to require us to factor it. It is in standard form, so we have to factor it, so it goes into factored form. So let's set up our dashes. Here we're going to find two numbers that multiply to make 10 that adds up to this middle number of negative 11. And those two numbers here are going to be, I think, 1 and 10. 1 and 10 does multiply to make 10, but you want to add those two to make a negative 11. What about if it's negative 1 and negative 10? Okay, let's see if that still works. Negative 1 times negative 10 is a positive 10. Negative 1 plus negative 10 is also a positive 11. All right, now we want to divide by the ax term, so we divide by 2x, divide by 2x. Let's see if it simplifies. The first one does not simplify, so it is just negative 1 over 2x. Then the negative 10 over 2x does simplify because 2 goes into each. This becomes negative 5 over x. So in factored form, it is 2x minus 1 and x minus 5, and we set that equal to 0. Here we're not done. It is in factored form. This is factored form. You are not done. Okay, we went from standard form into factored form with the process of factoring. However, we need to get to the solution. Okay, then how we set it, how we get the solution is to set each term equals to 0. So the first factor was 2x minus 11. We set that equal to 0. Then we have x minus 5. We set that equal to 0. This is the zero product property. Here we add 1 to both sides because they're linear, so we can solve it traditionally. 2x is equal to 1. Divide by 2 to both sides. This does cancels, leaving you with x is equal to 1/2. Here we have an x minus 5, so we're going to add 5 to both sides. The minus 5 and the first 5 cancels, leaving you with an x is equal to 5. So your solutions are x is equal to 1/2 and x is equal to 5. That here would be your two solutions. And again, it has to be two solutions because this is a degree 2. B, let's solve. And again, it's going to require us to factor, but first we have to make it equal to 0. So I'm going to subtract 2 to both sides. The right hand side does cancel, leaving you with a 3x squared plus x minus 2 is equal to 0. I write this in standard form. Next, we need to break it down, so we're going to factor it. 3 times negative 2 gets you a negative 6. The middle term here is a 1. So we're trying to find two numbers that multiply to make negative 6 that adds up to 1. Looks like that is 2 and 3. 2 and 3. One of them has to be negative. The 2 is going to be negative. Let's check. Negative 2 times 3 is negative 6. Negative 2 plus 3 is 1. Next, we divide by this ax term. So we divide by 3x, divide by 3x. Does this simplify? Yes. Becomes negative 2 over 3x. Bring this down. This does simplify because 3 goes into each. Becomes 1 over x. All right, now we have to write it in the parentheses in factored form, which is 3x minus 2 and x plus 1. And we have to set that equal to 0. We can now get it in the solution by setting each factor equals to 0. So 3x minus 2 is equal to 0, and x plus 1 is also equal to 0. We can solve this traditionally, so we're going to add 2 to both sides. The left-hand side does cancel, leaving you with a 3x is equal to 2. Here, we now divide by the 3 to both sides, so this cancels because x over x is a 1, because 3 over 3 is 1, leaving you with x is equal to 2/3. That is the first solution. Next, to do x plus 1 equals to 0, we subtract 1 to both sides, leaving you here with an x is equal to negative 1. Now, we are done because look, the x's are alone, so these are your solutions. So the solutions here are x is equal to 2 over 3 and x is equal to negative 1. And let's do C. Here, we have to again set it equal to 0, so we have to get rid of the negative 9x. So we're going to add 9x to both sides. Let's combine some like terms here. 12x plus 9x becomes 20, looks like 21x. Bring everything down. 6x squared plus 21x plus 15 equals to 0. Can we factor out? We can try to factor it, but we should always look for a GCF first. 6, 21, and 15 looks like they have a GCF here of 3. Okay? And let's see what is left over once we pull out that GCF of 3. 2x squared plus 7x plus 5 equals to 0. If you do not pull out the GCF, you're still going to get the same answer. It's just the numbers are bigger. So let's set up our dashes here. You're going to find two numbers that multiply to make 10. That adds up to this middle number of 7. And that looks like it is the number 2 and 5. Okay, 2 times 5 is 10. 2 plus 5 is 7. Divide by 2x. Divide by 2x because that is the a term. Let's see if this simplifies, and it looks like it does simplify. 2 over 2x becomes 1 over x. 5 over 2x does not simplify. That becomes just 5 over 2x. In the parentheses, it is x plus 1 and 2x plus 5. And again, we have to set that equal to 0. But remember, there's that GCF of 3 that is out in front. Don't not forget it. To get into the solution, we set each factor equal to 0. So we set 3x is equal to 0. Then we set x plus 1 equals to 0. And 2x plus 5 equals to 0. Now we can solve because it's all equal to 0 now. 3 is never equal to 0, so that's useless. To do x plus 1 equals 0, we subtract 1 to both sides. This cancels, leaving you with an x is equal to negative 1. Here we have a plus 5. We minus 5 to both sides. This does cancel, leaving you here with a 2x is equal to negative 5. Divide by the 2 to both sides. Divide 2 to both sides. This cancels, leaving you with x is equal to negative 5 over 2. Here you still get two solutions. The reason why you still get two solutions here, it is because this is considered to be a degree 2. And the fact it's degree 2, there's only two solutions.